Next slide.
Okay, so we are Team Marcus Pontes, and we have this name in honor of the first Brazilian astronaut, Marcus Pontes. Our team is composed by high school students, and we have the support of a college team called GFRJ, and we are from CEB, Centro Educacional Batista, in Brazil. Casimiro de Abreu, Brazil.
So, the Sun synchronous orbit is a nearly polar orbit with which the satellite is constantly moving direct to the Sun. We chose this kind of orbit because since the Earth would be between Mars and the Sun, the communication of the satellites and Earth would be easier. We also chose it because the illumination would be great for use solar energy, and since it's a nearly polar orbit, it will get through all of the points we chose, and the time is compatible with the Earth's time.
So now we're going to talk about a few areas that we think will be good to analyze and explore. The first one is Olympus Mons, and it was a volcano, and because of that, in the surface and around it, it has minerals such as potassium, sodium, and sulfur, and they can be good for the agriculture.
So the Abertwald crater has a relief and the presence of sedimentary rocks that then we can infer that there was a lake previously there. And we can also find clay, which would make the water's pH more neutral, be in a proper environment to support life and preserve better the fossils. It also has minerals that are good for agriculture.
The Equipe region were found the geysers. So because when they expel the water in the air, they also expel some particles, and because of that, the NASA, NSA, use a stratospheric balloons to collect these particles and analyze it. And we would like to use the same technology that they used.
The reason why we would like to use this technology is because some scientists believe that the particles ejected from the geysers has a biological origin, so we would like to analyze that with this technology using a microscope. So the Mount Sharp has boron, which is an element used to establish DNA pentoses, and life as we know now wouldn't be possible if there were any substance to realign the DNA structure as boron does.
So the Batista Borealis is a place where you can talk particularly. And if we use the theory that the life on Earth started on the water, that's one of the reasons that we would analyze the Batista Borealis, because particularly can be used as rocket fuel or oxygen source to anaerobic microorganisms, because they do chemosynthesis. And because it would be a place that could have existed water there, because of the water, the UV rays will not affect as much, because the atmosphere of Mars is very thin, and it's very thin. So the UV rays affect way more than it does in Earth, and because it would be in the water, it wouldn't affect as much.
So the lava tubes on Pavonis moons would be a great place to shelter human beings and be a source of water and energy.
Tesla Borealis is a big canyon, and because it has seasonal defrosting, it accumulates ice and dust, and we can use this accumulation to analyze the geologic past of Mars.
So now we're going to talk about places that accumulate substance in a probable presence of water. So the Hale crater has in its surface chains of channels that might have been created by a water flux. The Terra Sirena has deposits of chlorate that is only synthesized through the evaporation of water. And the Holden crater has clay, which is also only formed in water. And it's believed that the Holden crater was a lake before, and that one of the borders of it broke, creating a great water flux.
In Sigis Planitia, we found magnesium carbonate, which means that if there was water, it will have proper conditions for life. Eagle crater, there's a lot of hematite, that is a mineral that can only be formed in the presence of water. Columbus crater, and they found clay and sulfate, and then these are evidence that it might have been a lake. And here's this crater that had the presence of calcium carbonate and iron, which indicates that Mars had a thicker atmosphere of carbon dioxide and had abundant humidity. Those minerals and the presence of the clay are only found in humid environments.
So we're going to talk about places with important data about Mars past. The Schiaparelli crater has different thickness, and it's just an ancient climatic change resulted by the variation of inclination of the planet. The Hesperia Planum crater has a lot of impact craters that might indicate the planet's relative age, and the Stokes crater has hydrated minerals and also dark sand dunes made by strong sandstorms.
The leukocyte is a fracture on the Mars surface and suffered erosive process, and because of that, it was filled with sediment. And just like Chasma Morales, we can use to analyze the Mars geologic past.
The Milan-Kovic crater has 2 meters of frozen water underneath the surface, and the sign of the erosion exposed and shows evidence of new water discovered.
So the atmosphere in Mars. The major magnetosphere was lost 4 billion ago, and because of that, the solar wind interacts directly with the ionosphere, and that reduced the atmospheric density. And if we use the atmospheric in Earth as a reference, the atmosphere in Mars is very rarefied. The bigger atmospheric density found in Mars is equivalent to the atmosphere 35 kilometers above the Earth's surface. We have a beta project using a few sensors in Arduino, and most of the places we will use an imaging camera to analyze it. That's it. Can we finish the presentation?
We're done with questions.
Okay.
Congratulations, team. I have a first question. What is the most difficult topic you faced during your project?
So we were in charge of the orbit, the choose of the orbit, and the point of the trajectory. So we worked really hard to find these points, but we actually had a great time doing it. I've learned a lot, and I'm sure all the team did too. So there was a point where it was difficult, but we could work that out. So that's it.
Thank you very much. Apart from Mars, do you believe we have a good opportunity to use CubeSats in other solar systems exploration?
I think the why we use Mars so much is because it's closer, and we'll think about other solar systems will be a very it will be a lot more of work, but we could think about it too.
It's more challenging, but it's not impossible.
Yeah.
Thank you very much. Team, would you like to say a few words before we finish the presentation?
I think we would like to thank especially GFRJ because they helped us a lot, not only with the CubeSat project, but with a lot of other projects. And to anyone that helped us, our teachers, our friends.
Yeah, Yona from GFRJ gave this opportunity to us, and we are really grateful for that because it was an amazing experience. And GFRJ always trusted our work, and that's why we're here now. And also our biology teacher, who wouldn't like to be thanked for, but he's amazing, and without him, this wouldn't be possible either.
That's great. Great job. We are very happy and proud of you. And it was an amazing work. So if you don't have any other things to add, we thank you and we finish this presentation. Congratulations.
Thank you.